A forged motorcycle wheel starts life as a solid cylinder of aluminum. No spokes, no barrel, no shape at all, just a heavy, round blank. And by the time it's a wheel on a bike, most of that metal is gone, cut away, chips on a machine floor. What happens in between is 9 stages. Skip one and you still get something that looks exactly like a wheel. I'm on the supplier side of this. We manufacture custom motorcycle wheels in Chongqing, China. In this video, I'll walk you through all 9 stages in order, what physically changes at each one, where your lead time actually goes, and which stages are easiest for a supplier to quietly cut. This is the map. Other videos on this channel go deep on individual stops. Stage 1, the drawing. Nothing gets forged from a photo. Before any metal moves, we need geometry, rim width and diameter, offset, hub and bearing dimensions, brake disc bolt pattern, axle diameter, sprocket carrier, and the spoke design itself. That comes from one of 3 places: your CAD file, published fitment data for the platform, or a sample wheel you send us that we measure directly. It becomes a 3D model that you approve before we commit to metal. Here's the part most buyers get wrong. This stage costs nothing in material and almost everything in schedule. Far more wheel orders slip here than on the shop floor. Stage 2, material in. Next, the aluminium itself. Our forged wheels are 6061-T6, but at this stage, it isn't T6 yet. It's just 6061, arriving as billet stock or forging blanks. That certificate is where traceability starts. Everything downstream ties back to it. And it's a fair thing to ask for. If a supplier can't produce a mill cert for the batch your wheels came from, then the alloy is a claim, not a record. Stage 3, forging. Then the blank goes under serious pressure. Forging squeezes hot aluminium into a rough wheel shape. That compresses the internal grain structure and makes the grain flow with the shape of the part. That is the entire reason forged wheels exist. And it's a big enough subject that I made a separate video on it. Video 2 on this channel covers the metallurgy properly. For this walkthrough, what matters is the output. A forged blank that vaguely resembles a wheel. No spokes, no detail, just mass in roughly the right places. Stage 4, heat treatment to T6. The forging is strong now, but it isn't finished. To reach T6, it goes through solution heat treatment, a quench, and then artificial aging. That sequence is what turns 6061 into 6061-T6. 2 things worth understanding as a buyer. First, this happens before final machining, deliberately. Heat treatment moves metal. You want that movement to happen before you cut your final dimensions, not after. Second, T6 is a verifiable condition, not an adjective. Hardness testing on the batch is how it gets proven. So the useful question to a supplier isn't, is it T6? It's, how do you verify temper and can I see the record? Stage 5, rough machining. Now the blank gets its first cuts. Faces trued on a lathe, center bore established, datums set. This stage is unglamorous and it decides everything that follows. If concentricity is wrong here, no amount of beautiful spoke machining rescues the wheel. You just find out later as run out on a balancing stand. Stage 6, CNC finish machining. This is where the design comes to life. Spoke profiles, rim barrel and bead seats, valve hole, disc and sprocket mounting faces, bearing bores. This is the single longest block of machine time in the whole process. And on a one-off custom design, it's also where programming time lives. Video 8 goes inside this step properly. Stage 7, deburring and hand finishing. Off the machine, a wheel is not ready for anything. It has tool marks and sharp edges. Deburring, edge breaking and surface prep, brushing, polishing or blasting are done by hand, one wheel at a time. There is no shortcut here, which is exactly why it's one of the first stages a low-cost supplier quietly trims. You see the result as a rough spoke root or a sharp bead edge. Stage 8, surface finish. Then the wheel gets its final look. Anodizing adds thickness. It changes the dimension of the part slightly. So bearing bores and other critical fits have to be masked or machined with that in mind. Video 14 covers the finishing room in detail. Product lines and finishing options are on our website. Stage 9, measurement, assembly, packing, last stage. Dimensional check against the drawing. Radial and lateral run out. Bearing fit, then bearings, valve and any hardware go in. The wheel doesn't leave with a marketing claim attached. It leaves with a record, one that ties back to the mill certificate we started with in stage 2. So if a custom wheel order takes weeks, which of those 9 stages eats the calendar? Almost never the machining. It's these 3. Drawing approval, because it depends on you, not us. Heat treatment, because it runs in batches. And finishing, also batched. And color changeovers cost time. Anyone quoting you a hard lead time before approval is just guessing. Now the stages that get skipped when the price gets pushed too low. 3 common casualties: documented temper verification, hand finishing time, and final measurement replaced by a quick spot check. None of the 3 are visible in a photo, but all 3 are visible on the bike eventually. I've got a separate video on how to spot a supplier cutting corners. That's video 5. That's the full route: billet, drawing, forging, heat treatment, rough machining, CNC, hand finish, surface finish, and measurement. If you build, import, or sell wheels and you want the deeper stops on that map, subscribe. I'm publishing 1 stage at a time. Product lines and platform fitment are at FLEXIMOTOWheels.com. Explore our forged and cast collections. And if you've got a wheel you need made, send me the drawing or the sample specs and I'll come back to you inside 48 hours. I'll see you in the next stage.